Let's start by understanding what a couple is in physics. A couple consists of two forces that are equal in magnitude, opposite in direction, and parallel, but crucially, their lines of action do not overlap. Because they cancel out translational effects, they produce only a rotational effect. The result is torque, a pure turning force. The formula for the moment of a couple is one of the forces multiplied by the perpendicular distance between their lines of action. This configuration causes no shift in the center of mass, only rotation. Now let's look at the characteristics of a couple. The most important point is that a couple causes no linear motion. Why? Because the two forces cancel each other out directionally. The only outcome is rotation. The turning effect is always around a central axis, and interestingly, the effect doesn't depend on where the forces are applied, only on how far apart they are. That's why tools like screwdrivers and steering wheels are designed for maximizing this separation and therefore increasing torque. We see couples in action in countless daily activities. When you use both hands to turn a steering wheel, each hand applies a force in opposite directions, creating a couple. Twisting open a bottle cap or turning a doorknob. That's also a couple. Even the motion of a grinding stone, rotated with two fingers pressing on opposite sides, demonstrates the same principle. In all these cases, no matter where the forces are applied on the rim, it's the distance between them that generates rotation. Let's now discuss equilibrium. A body is said to be in equilibrium when all forces and all turning effects acting on it balance out. This can occur in two forms: static equilibrium, where the body remains at rest, and dynamic equilibrium, where it moves with constant velocity. For true equilibrium, the body must experience no linear or angular acceleration. That means both net force and net moment must equal zero. There are two main conditions to achieve equilibrium. First, the sum of all external forces must be zero, ensuring no net push or pull in any direction. Second, the sum of all moments about any point must also be zero, ensuring the body doesn't rotate unexpectedly. Mathematically, we say net force equals zero and net moment equals zero. These two conditions together define mechanical equilibrium, which is the basis for understanding structures, machines, and statics. Let's try a numerical problem. Two equal and opposite forces of 15 newtons are applied on a wheel separated by a distance of 0.4 meter. To calculate the moment of the couple, we multiply one of the forces with the perpendicular distance between them. That's 15 times 0.4, which gives us 6. So the moment of the couple is 6 Newton meter. Since this pair of forces causes pure rotation without translation, we confirm that it forms a couple. To recap, a couple is a pair of equal and opposite forces that rotate a body without shifting it. The moment of the couple depends on one of the forces and their perpendicular separation. Equilibrium is achieved when both the net force and the net turning effect acting on a body are zero. These ideas are foundational for designing stable structures, analyzing machines, and understanding torque-based systems. Next, we'll build upon this by learning about one of the most powerful balance tools in physics, the principle of moments.